Okay, time to show you a combined gas law problem that involves pressure. Actually, it involves all three variables, pressure, volume, and temperature, but as you can see here, I'm really focusing on a problem that solves for pressure to show you what that looks like. All right, so let's read the problem together and we'll figure it out. Okay, so it says a sample of gas occupies 15 liters. And it's a good idea to underline these numbers just to make them more obvious. And so let's continue. So a sample of gas occupies 15 liters at a pressure of 2 atmospheres. All right. And the temperature is 50 degrees Celsius. Now, if the volume is lowered to 5 liters and the temperature is increased to 80 degrees Celsius, what would the new pressure be? So we're really focused on looking for the new pressure. All right. Couple of things before we begin. First, you must make sure that the temperature is always in Kelvin. All right, that is for sure. So always make sure that the temperature is in Kelvin. How do you do that? Real simple. Take the degrees Celsius. You're going to add 273, and then that gives you the temperature in Kelvin. Okay? All right, so let's figure out what information has been given here. I've underlined all the important numbers, but the equation is P1 V1 over T1, right? The little 1 stands for the initial conditions, equals P2 V2 over T2. That little 2 represents numbers associated with the final conditions. Okay, so this is what you start with, and this is what the conditions are after some change has occurred. Okay, so we know that this is our initial volume because it's in liters. Here we've got a pressure because it says atmospheres, and we measure pressure in atmospheres, so this is our P1. Now the temperature for the initial conditions is 50 degrees Celsius. So that's our T1. But since it's in Celsius, we're going to need to change that into Kelvin. Very simple. Like I said, you take 50, you add 273, and that's going to be equal to, let's see here, 323 Kelvin. Now it's important to note that your teacher may want you to use a more accurate number than 273. It could be 273.15. So depending on what your teacher recommends, this number may be different, but I'm showing you the general strategy for how this equation works. I don't want to get too caught up in the details. Okay? I'm sure somebody would call me out on it though. All right. Anyway, let's go back to the problem. So we figured out V1, P1, and T1. All right, so we've got our initial conditions here all figured out and labeled. Now, buried in here, you see that there's the volume is lowered to 5 liters. Okay, so that's the Q, that's the sign that we're dealing with a volume. Whoops, that's 5 liters, so it has to be a volume. And that's the new volume. Okay, so that's V2. Over here, it says the temperature is increased to 80 degrees. So I'm going to kind of sneak some room down here. That's our T2, and it's 80 plus 273. So let's see what that is. 80 plus 273, that's 353. All right, so that's our second temperature. The new pressure, that's going to be P2. Okay? So I know it's a little confusing if you take a look at this. If I were to just show you this right away, a lot of this stuff would be confusing. But I've decoded it slowly, and if you need to go back and watch how I decoded this problem again, please do so. Okay? Feel free, because decoding a problem is half the battle. All right, so now that I've got all the important numbers figured out, you'll see that I've also labeled them so that I don't make a mistake about which number is supposed to go where in my formula. All right, I'm going to use this formula now to find my answer. So here we go. So for P1, it's 2 atmospheres. So I'm going to write 2 atmospheres. The V1 is 15 liters. T1 is 323 Kelvin. Now on this side, P2 is what I'm looking for, so I don't know yet. So I'm just going to write P2. V2 is 5 liters. And then the T2, which is supposed to go down here, that's 353 Kelvin. Now you see what I missed out on here? Bad boy. All right. Got to make sure that you put the units in everywhere you go. You don't want to leave anything without units. Okay? So now I've got the problem set up nicely. You can see that liters matches with liters and Kelvin matches with Kelvin. This is a very important check just to make sure before you proceed, make sure that the units are consistent. Now, if the pressure was given as 2 atmospheres, guess what? When you solve for P2, the units are also going to be in atmospheres. All right, so how do we solve this problem? Well, ideally we would multiply both sides by 353. So if I did that, multiplied this side by 353 and this side by 353, this is what you would get. Now from this point on, I'm just going to concentrate on the numbers. Okay, so if I multiply this side by 353, multiply this by 353, the 353 that was down here goes away, right? Just like a good algebra problem. And then I'm going to divide both sides by 5, all right? And so if I divide this by 5, which probably looks a little weird, okay, if I write like a big line down here, now it looks like really ugly. But in essence, what I'm doing is 353 times 2 times 15 divided by 323 divided by 5, okay? So I know it's a bit close, but this is where we're at right now, okay? Now to solve for my final answer, right, which is what we've been trying to get to this whole time, we have to carry out some multiplication, little division, right? So 323 divided by 5, and there is our answer. So we've got 6.56. Remember, this is a pressure, so our units must be in atmospheres. All right, now that is the entire problem solved out, okay? Believe it or not. Okay, so the only part that I could see being a little confusing would be probably 2 things. One, decoding the problem, and then this little maneuver right down here, okay? I know it looks ugly when I divided both sides by 5, but if you remember back to the days where you were doing your algebra lessons, if you divide something by 5, it basically just means that it's going to be added into the denominator, okay? Or I shouldn't say added, but it's placed in the denominator. How's that? It's probably better math speak to say that it's placed there, okay? So if I have a fraction and I divide that fraction by 5, then the 5 goes down here, and then, you know, solving this out is a piece of cake thanks to the handy dandy calculator. Okay, so that's the combined gas law problem. We solved for P2, we are done, and you need to practice. So make sure that you solve enough of these kinds of problems until you get consistently correct answers. And if that's true, that's good evidence that you've got it down. Okay? All right, that's it for now. Practice some more problems, download the free worksheet, and see if you can solve this on your own following all the steps that I did.